A typical action that we may want to do on a surface is to read and possibly modify the content of the image. Let's consider a surface that represents some image. Now, let's zoom inside a small part of the image. As we can note, an image is just a rectangular area containing many pixels. Each pixel is made up by at least 3 components, the red, green and blue color components. It's also possible that a 4th component is present, the alpha component, which controls the transparency level of the pixel. In our C++ code, we may want to read and modify these components of some or of all pixels that constitute an image, represented using instances of the surface class. It's very important to be aware that the red, green and blue color components, as well as the alpha component if present, are just numbers. In the case of the surface class, they are just 8-bit unsigned integers. So each pixel is a set of numbers. Consequently, each surface that represents an image points to some memory inside the computer, memory that just contains numbers. All in all, the surface image in memory is represented by an array of numbers. So, how can we access the pixels inside a surface? The answer to that question is to use surfaces iterators. This simple C++ code snippet shows an example of this surface pixel iteration pattern. We start requesting an iterator object to iterate the pixels in the whole surface. To do that, the surface getIter method is called. The return value of this method is an iterator object that we can use during the iteration process. The iteration process is made by 2 nested while loops. The outer loop iterates through each horizontal line of the surface. It starts from the first line, then it goes to the second row, the third row, and so on, for each horizontal line in the surface. To advance the current line, the iterator is pointing to, the line method of the surface iter class is called. The inner loop iterates through all the pixels in the current horizontal line, starting from the leftmost pixel to the rightmost pixel in that line. To advance the current pixel the iterator is pointing to, the pixel method of the surface iter class is called. And now, inside the loop's body, we can manipulate current pixels components, using the R, G and B methods of the surface iter class. For example, it's possible to apply some kind of filtering or other forms of image processing to the surface, changing the values of these color components. In the previous slide, I showed how to iterate through all the pixels in the surface. In addition, it's also possible to iterate through the pixels inside a given area of the surface. To do that, we can use the Cinder area class. We can create an instance of the area class, defining a rectangular region inside the whole surface. This sub-area is defined by its left top and right bottom pixel coordinates, as we can see from this code snippet. Then, we can call the getIter method of the surface class, passing the area object defined above. The iteration loop remains the same as the one showed in the previous slide.